My name is Joanne Cheng. I work for Thoughtbot out in Denver, Colorado. So if you look at that red dot in the middle of North America, that's where I live. These are all of our offices, and the red dots represent how big the offices are, if anyone's curious about how we're distributed at Thoughtbot. So I do mostly web development with Ruby on Rails and JavaScript, but I've also been fascinated by the field of data visualization for the past several years. Data visualization, simply defined, is the study of graphical representation of data. And today we're mostly going to be talking about data visualization in a web context. So I was going to make this talk about creating crazy graphics with D3.js, which is a JavaScript library commonly used to make complex data visualizations on the web, like the ones you see here today. But data analysis and visualization isn't about the craziest, most unique ways to display data. It's about looking for stories in data and communicating those stories with graphics in the best way. And sometimes you do need to be creative, and sometimes you need to use other forms of visualization. And one of my favorite creative data visualizations isn't a D3 or a JavaScript example. It's a print example. This is a map by a physician named John Snow from the 1850s. So he's a doctor at the time. And in around 1854, there was this cholera outbreak in London. And the theory was that the cause of death and the cause of this outbreak was caused by pollution or bad air. But John Snow was skeptical of this theory. And his theory was all these deaths were caused by this one contaminated water pump in the middle of Broad Street. It's a little hard to see the markings. But what John Snow did was he created bar graphs that plotted out the deaths per building. And so you saw a concentration of deaths around a certain water pump. And because of this graph, or because of this map, he was actually able to convince health officials to investigate that water pump. And they found that there was, in fact, cholera bacteria in that water pump. And so that's what's great about amazing data visualizations. It causes people to react and take action. So how do we translate this into the context of web applications? I really like to think of this as three main ways of displaying data on web. We can have text, so HTML, tables in HTML. We could even just use plain text or JSON or other formatted data. We could use a graphing library where we can just throw in data, something a little bit more configuration based. So we basically tell it, we give it data and we tell it what to give us. And it gives us back a pre-made graph with our current values. Or we can use something that's a little more custom, something like D3.js. So D3.js, like I said before, is a JavaScript library used a lot for data visualizations on the web. But it's not so much a data visualization library as a way for you to map data to elements in the DOM, usually to SVG. It was created by Mike Bostock of the New York Times, and it's used a lot to create really custom visualizations for newspapers. It's a little hard to explain D3 without a live demo, so let's jump into an example of how it can be used. Let's wait for everyone to sit down for a bit. So I've always been curious about how open source communities work. And I work with Rails nearly every day, and I know it's a very active project on GitHub. So I chose Rails, the open source project, as a data source. And before I dove into this data, I didn't really know what to expect from the data I would find on GitHub. So I started with asking a really simple question. How can we visualize the Rails community? It's a very broad question, but it led me into asking what data to look for. And so eventually I settled on issues on GitHub, on the Rails open source project. Some things that jump out at me, if you can see, there's a couple of fields that I think are really interesting. The title, the labels that every issue has, the state of the issue, whether or not it's closed or open, the number of comments that the issue has, the created at date and close at date, and the pull requests. And this is usually what I do when I dive into a data set. I like to look at individual facets, and I like to just kind of look for interesting attributes. And also when I dive into a data set, I like to use a library called highcharts to give me really basic graphs. So this is just open versus closed issues on Rails, and I split it out into pull requests and issues. And it's just a very simple graph, but it helps, and I make a lot of these, and it helps me understand the data a little bit more. But the problem with those graphs is that I can't really see a lot of these attributes at the same time. So I got out my sketchbook, and I had this idea of representing issues in like these little bubbles. So the size of the bubble, whether or not it was bigger or smaller, would actually represent the number of comments on the bubble. And the darker the color or the lighter the color, that means the less time, or the darker the color, the less time it's been open. And the lighter it is, the more days it's been open. If the issue hasn't been closed yet, I would outline it with this little dotted line. I would also color pull requests blue, and then also just plain issues without pull requests, this dark gray black. And I'm going to show you how to create this visualization with D3.js with some issues I've already collected. And the data is going to look, for every issue, the data is going to look like this. We have these 4 fields. We have the age and days. We have whether or not it's a pull request, number of comments, and the state. So I'm going to fiddle with this. You guys can all talk to each other, try to get to know your neighbor while I set this up. Okay, so I'm actually going to be using CoffeeScript for this example. Is anyone like religiously against CoffeeScript? Okay, so I have just a blank, almost blank JavaScript or CoffeeScript file, and I have an almost blank HTML file. Except I have this little content div over here. I have this div with the class content. And so the first thing I need to do is add an SVG container in order to actually draw SVG on this page. So to do that in D3, I select that content div, and then I just append an SVG element to that D3 object. And it's a little hard to see, but there's an SVG element created in that content, in that div over there. And so now I have this SVG D3 object, and I could actually attach attributes to it. So I could set the width, and I could set the height. And so if you can see, there's now attributes in that SVG element. Now the width is 1400 pixels, and the height is about 2400 pixels. And now I need to populate it with data. So I'm going to use this D3 helper method called JSON. It's basically like a jQuery get method. You pass in a URL, and then it takes that JSON object and turns it into a JavaScript object. And in this case, it's an array of JavaScript objects, all with those attributes that from the issues. So now I want to create these circles that I was talking about before for every one of these issues. So I take that SVG D3 object that I created on line 6, and then I select all circle, which is an SVG, circle is an SVG element with the class issue. So these SVG elements don't exist yet, But it serves, that select all statement serves as a placeholder for the ones we're about to create. So these lines I just added, on line 13, I call a data method and I pass in that array of issue information. That's binding the data to that D3 object. Then I call enter. What enter does is for every element in the array, it's going to call all the methods chained on enter for every element. So what it's going to do is for every element of the array, it's going to append a circle and give that all of those circles a class of issue. That class method just sets the class attribute to issue. So if we refresh this page, we don't see anything yet because we don't have a radius or any or a position for any of the circles. But we can see that we have all of these circles that are created. So now we actually have to draw them by adding more attributes. And so circle is an SVG shape. And so all of the attributes I'm going to be setting, you can look at the SVG spec and get all the attributes that you're going to need for whatever element you're drawing. So now we have a lot of circles. And so going back to the code, what we're doing is we're just setting attributes. CX means the center position of a circle. CY means the center Y position of the circle. And R stands for radius. And when we have this adder function, or adder method. And so when we call the adder method, we could either pass in a static number or a static value like that, or we can actually pass in a function. And so when we pass in a function, we get two parameters. D represents the element of the array that we're on, and I represents the index of that element. So these two lines here, all it's doing is it's laying out the circles in a grid by taking that position and calculating where it should be. I also need to move this over because some of it's getting cut off. So I'm going to call this transform attribute and I'm going to translate it by moving it 40 pixels down and 40 pixels to the right. And this is, this is another SVG thing. And there's more documentation on the SVG spec. So I want to actually attach attributes to each of these circles that represent our data. First thing I want to do is change the color based on whether or not it's a pull request. So what I just added on these three lines, or on these multiple lines, I'm setting the fill attribute, which is another SVG attribute, and I'm checking to see if that element that we're drawing, if is pull request is equal to true. If it is, then steel blue gets returned. If not, a dark gray gets returned. So CoffeeScript has implicit returns, which is why you don't see any return statements here. And so this is how the colors change. So all the blue circles represent pull requests, all the gray circles represent issues. Now I want to draw the outline by looking at this. I want to draw the outline based on the state of the issue. So now you can see that some of these circles have this dashed outline. That's showing that the state is still open. So what I did here was I just set the stroke, which is the outline of the circle, to black. I set the stroke width to 2. And then this attribute dash array, the stroke dash array, basically just lets you define a type of dash line around for all of the lines that you're drawing. So if it's open, I want it to return a certain value. 3 represents how wide each black line is. 2 represents a space between each black line on the dash. And if there's no, if the state is closed, I don't want it to return anything. That way we still keep that solid line. So now I want to make the color, or the shade of the color that we have on the issue, or on the circle, represent the age in days. So I'm going to change the value of opacity. Opacity takes a value between 1 and 0, or 0 and 1. And this age in days attribute can go from 0 to, let's say, 60 for argument's sake. So we need a function that translates that age in days number into a value between 0 and 1. And so D3 comes with all these helper functions that let us create functions that translates these numbers into numbers we want. And they're just called scales in D3. So I'm going to create a scale function for to return the right value for opacity. Now we can see some of the circles are a little bit lighter. So what this function does, so d3.scale gives us an object with all these different scales that we can use. I chose a linear scale because we want a one-to-one mapping of the domain and the range. So the domain is the input. That's the number that we're going to give to this scale. And the range is the output. That's the range of numbers that we want back from the scale. So if we had so for example, if we pass in a number of 0, that function, that age in days scale function, is going to give us 1. And that's what we want. We want the lower number of days to be more visible. And so for the size of the circle, we have to do something similar, except we're going to be changing the value of the radius. And now we have, now the size of the circle represents the number of comments we have. And so what I did on line 16 was I created another scale. This time I had to use an exponential, or I had to use a different kind of scale because, so to calculate the area of a circle, we need the square of the radius. So if we just use a linear scale, that means the area of the circle would actually increase exponentially, which we don't want. So we needed to create a different type of scale for this. And that's really it for the example. It was about 40 some odd lines of code. So this example that we just created, it isn't complete. For instance, we would probably need a legend if we were ever going to present this. And there's a lot of more interesting things to do. Maybe we want to group all these issues and pull requests by the labels and tags that they have, because some of them are grouped by what class in Rails that they reference to or the release number. And maybe we want tooltips to show the actual, to show the title and the body and like the comments that people have made on each pull request. But it's an interesting way of looking at the data. Sorry. So it's an interesting way of looking at the data, and I think it's also like visually appealing. And usually when, and I find that when visualizations are like more aesthetically pleasing, people spend a lot more time on them, and they kind of have more fun digging into a visualization and trying to understand it. So I also created another visualization for this talk. I was kind of curious about when issues get created. I was interested to see if there was any interesting I was interested to see if there was any trends or correlation between issues that get created and release dates. So I just took all the created at dates and mapped them on or put them on a line graph using highcharts.js. And I first noticed that huge spike. That was the day that they imported, the Rails project imported all of the issues from another issue tracking system that they used. So going through that, I normalized the data by removing that date and all those Lighthouse issues. And I saw that there were some interesting spikes. At first I thought, so there are some interesting spikes. For instance, a lot of issues get created around the beginning of 2012, and that's when Rails 3.2 was released. I thought that was pretty interesting. But I also couldn't see when issues get closed. So I had this idea of creating this timeline diagram where I could see the lifespan of an issue on a horizontal timeline like this. And so I just looked at these two attributes of every issue, and I tried to map them out on a timeline, and it came out a little messy. So first thing I did to clean it up a little bit was to increase the opacity of the line, so that way you can see kind of groupings. So the darker the area on the timeline, the more issues were closed. Also, if an issue hadn't been closed yet, I just made the closed at date the day or today, or I date that a new date object. But I can see that there's some like dark spots, but I couldn't see if they correlated with any releases, because so that was disappointing. I thought that was going to reveal something interesting. So then I asked myself if issues or pull requests gets closed faster, and so I split out that view into two different views, one with just issues and one with just pull requests. And I couldn't really find much except for that same dark spot in May 2012. I tried to split it out in color, so the gray lines represent issues that haven't been closed yet, and the blue lines represent issues that were closed. I couldn't find any interesting data other than there's a lot of issues that are still open from like 2011, whereas pull requests there's a lot fewer. But it was an interesting way of looking at the data. I've never really seen pull requests or issues like this before. I thought it was an interesting way of looking at open source, so I thought it was a mild success, although not really. So this talk was mostly inspired by this question I get a lot, which is how do I get into data visualization and analysis? And many people have actually recommended tools like saying learn R or learn Python. Many people say that Ruby developers like myself, that Ruby is not suited for data analysis. But these are all the technologies I used for this demonstration. Highcharts and D3, of course, but I use Ruby on Rails to collect my data and to just create JSON and do some really quick analytics. And you can adapt your own technologies to help you with data analysis. Because the important part of data analysis is not really the tools that you use, but the process and the reasonings that you have behind your results. You want to be inquisitive of your data. You want to keep asking small questions about your data and try to get quick feedback. And yes, you want to keep your questions simple so you can get more out of your data, especially out of large complex data sets, because it's really difficult to get a big idea or to get the big picture of such a large amount of information. So you have to think iteratively. And I was hoping to show that iterative process by going through some of my some of the examples that I showed you before. And you also want to create the visualization that answers your questions. Sometimes a simple bar chart or even a single number will be the visualization that you need, but sometimes you need to think a little bit more creatively. And adding D3 to your toolbox will let you be able to express your data with a lot less limits on the web. And we touched on the very basics of D3 today. There are tons more features of this library that can help you express anything you need from your data. So that's it for my presentation. Are there any questions?
Questions, anyone?
The one with the pull request, so where you have the arc. So the one chart you did with the pull request where you had the arc, that's all high charts, or?
Oh no, this is all D3.
That was all D3. Okay.
Sorry, I should have made that more clear.
Anyone else?
Thank you. Are there any examples of D3GS doing visualizations on maps, either with coloring regions or even having charts over a map?
Yes. No, not this page. Oh, sorry. Did you want to see the examples, or did you just want a yes or no question? I was going to show.
If you want to show examples, it's great. Yeah.
I mean, so this page is really. Oh, this is not mirrored. Sorry. So this page, which is Mike Bostock's GitHub page, Mike Bostock being the creator of D3, has like a lot of really experimental small examples. This is kind of a really basic. So what you have to do though with this is you actually have to have JSON files that represent the geography that you want. It's not so much like mapping isn't really built in. But there's a lot of functions that can help you build maps and build visualizations on top of maps.
How would you? What would you need to do in order to draw the regions? How would they be drawn?
So you need shape files.
Shape files.
You should talk. It's a little hard to explain right now, but
KML
talk to me.
files or something like that.
Hey, have you used any of the libraries built on top of D3, like NVD3 or Rickshaw or something? And what's your opinion on that?
I like NVD3. It's not as well documented as I liked, but with NVD3 and generally libraries built on top of D3, if you do a little bit of digging, you can actually like customize your graphs to look the way you want. So a lot of designers I work with actually really like NVD3 because they just have to change, in order to change the style, they just have to change the CSS.
Okay, thanks.
I was wondering if you have any experience with sort of interactive visualizations where you can really sort of explore your data, and if D3 has features specifically to help with that?
Yes. So you can actually set callbacks on all of the. So in this example, let me actually open up the code a bit again. Do I have time for just a quick coding? Okay. So. So D3 has methods that let you write callbacks and mouse actions. So I think it's mouse over, and then so every time there's a mouse over on any of the elements, you can have an event fire, and then have a function. So I'm just going to go print out the title every time I mouse over a circle. Whoops, that's not supposed to happen. Okay, So as you can see, there's every time I mouse over a circle, the title of the pull request gets pulled up. So yeah, you can attach mouse handlers for interactive visualizations.
Thank you so much.